Hi children, welcome to my YouTube channel. This is third video of the video series Surds. In this video, we are going to discuss about the rationalizing the denominator. What is rationalizing the denominator? We know that if you get a fraction somewhere like this, here the denominator is a term including with the square root. This kind of a fraction, if you consider, you can obtain that this is come up with the irrational denominator. Then making this fraction into a form of this, where the denominator is a rational number, where you can get this answer without a square root, that is called the rationalizing the denominator. Simply, if I explain this rationalizing process, you get a fraction with a denominator with a square root or a cubic root itself. We convert into a form without any root expression in the denominator. That is a simple idea of rationalizing the denominator. Before we learn how to get the rationalizing the denominator, we should understand that what is the purpose of doing it. So what is the problem if you are having a square root answer in the denominator? For example, if I want to simplify 1 divided by root 2, suppose that you don't have your calculator, then we know that 1 divided by root 2 is 1.41423. It's going to be infinite decimals. If you consider this number itself even, it's very hard for us to divide it. You can say it's kind of very difficult to do this division. I will rationalize the same fact over here. It will turn up to a form like this. If you rationalize this, we will learn how to convert into this rationalizing form from this fraction. If you convert this fraction into this format, it will convert into this. And you can say that that simplification is quite easy. That is one use of getting rationalizing the denominator. Now let's see how to do the rationalize the denominator. Initially, we'll start with a small, some kind of an easier fraction with a single square root in the denominator. Let's see how to do the rationalizing. The simple concept of rationalizing denominator is multiply the numerator and denominator by the same surd fact in the denominator. That means here the third answer is root 6. I'll multiply both numerator and denominator by root 6. That one obtains you 5 into root 6 is 5 root 6. Root 6 into root 6 is how much? Root 36, or other way around, root 36 is 6. With that you can obtain the answer 5 root 6 over 6 as the rationalized version of the fraction 5 divided by root 6. If you work out in this example, here 2 divided by root 3, then what can you do with this? So you can multiply both numerator and denominator of 2 root 3 by root 3. Then 2 into root 3 is 2 root 3. Root 3 into root 3 is root 9, that is 3. If you are not sure about it, use your calculator and multiply root 3 with root 3 and see whether you can get the same answer. Okay, in this example, we have to rationalize the denominator of root 2 over root 3. Then root 2 over root 3, we have to multiply both numerator and denominator by the denominator expression, third expression. So root 3, multiply both numerator and denominator by root 3. Root 2 into root 3 is root 6. If you are not familiar with this, refer our second video of Surds. I will put the link at the top corner even, or in the description box also it will be mentioned. So with that you can get a clear idea how to do this multiplication. Then root 3 to root 3 is 3. That is how you have to get the rationalized version of this irrational number. If you consider 2 root 5 over 2 root 3, then what you can do? You can multiply 2 root 5 over root 3 by root 3. And root 3 numerator and denominator both should multiply with root 3. Then 2 into root 5 into root 3 is root 50. Root into root 3 is root 9, that is 3. So therefore, your answer is 2 root 15 over 3. Then, if you multiply this, 2 root 5 over 7 root 3, then this number should multiply by the third part only. Right? If it is not involved with addition or subtraction, it's a different story. We will do it later. For the moment, what is the third, what do you call that? What is the irrational part of this denominator? That is root 3. Then multiply both numerator and denominator by root 3. Or if you feel like this is hard, you just multiply even 7 root 3 numerator and denominator both. That one also doesn't matter. Finally, it will simplify. No worries with that. So if you are much familiar, you just multiply the rational part over here. Then if you multiply root 3 with root 3, 2 into root 5 into root 3 is root 15. That is 2 root 15. 7 into root 3 into root 3. Root into root 3 is how much, children? That is root 9. That is 3. 3 into 7. That is turn up to 21 in another way. If you get 7 root 3 into root 3, 7 root 9. You can multiply the third answer. Root 9 is 3. 7 into 3 turn up to 21. Hopefully you can understand how to rationalize that denominator. Let's come up with the denominator with some kind of algebraic expression. So you have to simplify 2 divided by root x. Then what you're supposed to do? Multiply both numerator and denominator by root x. Then 2 into root x is how much, children? 2 root x. Right? You cannot multiply the term inside the square root by outside. We already learned in our previous video. If you are not familiar, please refer that video again. Right? Then what is the answer for root x into root x? That turn up into x. So look at the previous examples. Root into root 3 is 3. Here also, so if you work out over here also root into root 3 is 3. So if you look at another example, root 6 into root 6 is x. Similarly, if you multiply with root x into root x would be x. The square root get cancelled over here, right? So your final answer would be 2 root x over x, right? Then if you come up with this example, 2 root x over root y, then you have to multiply both numerator and denominator of this fraction by root y. Because that is the denominator is root y. Then 2 into root x into root y, you can multiply these two terms. Square root of xy. Simply, if you multiply terms inside the square root, you can just multiply them together. Root y into root y is how much, children? That is y. The same operation what you have used. So your final answer would be 2 root xy divided by y would be the final answer. Then, now this is the next case, right? Here this denominator combined with another number. In that case, you cannot just multiply by root 3 to make them into rationalize. So in this case, we multiply both numerator and denominator by the opposite operation of this. This is called the conjugate operation. If this is plus, you have to multiply with minus in between. Root 3 plus 1. If the denominator is root 3 plus 1, you have to multiply both numerator and denominator by root 3 minus 1. Then we'll do the operation. 2 into root 3 is 2 root 3. 2 into minus 1 is minus 2. When you multiply these, children, you will understand that root 3 into root 3 is 3. We'll keep it as it is 3. Root 3 into minus 1 is minus root 3. 1 into root 3 is plus root 3. That minus root 3 and plus root 3 get cancels if you expand the brackets. 1 into minus 1 is minus 1. Then it will turn up to 3 minus 1 as 2. If you feel like this is confusing, at the rationalizing, when you mark it like this, you can just multiply this. 3 into root 3, that is root 3 into root 3, sorry. Root into root 3 is 3. Plus 1 into minus 1 is minus 1. 3 minus 1 is 2. Then I can divide both by 2. That's why I just simplify over here as root 3 minus 1. So if you're able to obtain this answer, that is quite sufficient. This is the further simplification of this, right? Okay. Then how to rationalize this? Now consider the denominator, root 5 minus 1. From which number you have to multiply? You have to multiply with root 5 plus 1. Opposite operation of this. Root 5 plus 1 numerator and denominator. 3 into root 5 is 3 root 5. 3 into 1 is 3. Then denominator. Simple operation what I taught you is root 5 into root 5 is 5. Minus 1 into plus 1 is minus 1. 5 minus 1 is 4. Because when you multiply, obviously, these intermediate terms get cancelled with the third expression, right? Okay, that is how you need to obtain the answer for this question. Yeah, let's work out few examples, right? Over here, I have to simplify. 1 divided by root 5, what we need to do is rationalize denominator. Multiply both numerator and denominator by root 5. 1 into root 5 is root 5. Root 5 into root 5 is 5. This is your final answer. P is 1 over root 11. 1 over root 11, both numerator and denominator by root 11 itself. 1 into root 11 is root 11. Root 11 into root 11 is 11. This is the final answer. 1 over root 2. Both numerator and denominator by root 2. 1 over root 2 is root 2. Root into root 2 is 2. So this is the final answer. If you come across this equation, root 3 over root 15, what you can do? Multiply both numerator and denominator by root 15. Root 3 to root 15 is root 45. Root 15 to root 15 is just 50. Then you can simplify this root 15 further. We know that 45 is 3 into 3 into 5. That is 3 into 3. There's a couple. You can take the 3 out. Turn up to 3 root 5 divided by 50. Then other way you can write it as root 9 is 3 into root 5. Root 9 is 3. 3 and 15 get cancelled. That is why this turn up into 5 into root 5. So that is root 5 over 5. If I explain it again here, 9 into 5 is 3. Root 9 is 3. 3 into root 5 over 15. This 3 and this 15 get cancelled and turn up to 5. Then this 5 root 5 remain over here. Root 5 over 5 would be the final answer. Then if you work out over here, right? Then root 12 over root 48. Then this is pretty simple. No need of going any kind of rationalization. Or if you want, you can rationalize even. Root 48 is root 12 into root 4. Then what you can do? Root 4 is 2. Root 12 and root 12 get cancels each other. Root 4 is 2, so it will turn up to 1 over 2. That is a simple idea of simplifying this. No need of doing rationalization. If you want, you can do the rationalize and simplify even. You get the same answer again, right? This question also same condition. I don't feel like you need to do any kind of rationalization. Here, first you can say the root 80. Root 80 is 2 into 2 into 2 into 5. So 4 times 2 into 2 into 2 into 2 into 5. Then that is root 16. We know that root 16 is how much, children? Over here you can write 4. Root 5 and root 5 cancels and turn up to 1 over 4. Root 16 is 4. Root 5 get cancels. 1 over 4 would be the final answer. Right. If you come up with this example, this one also the same situation. You can see root 12 and root 156. Again, 156 you can write 12 into 30. Then you can cancel these two. Turn up to 1 over root 13. Now you need to rationalize it. Right. How to do it? You want to multiply both numerator and denominator by root 13. Then 1 into root 13 is root 13. Root 13 to root 13 is how much, children? That is 3. So your final answer is root 13 over just 13. Right. Over here, 7 over 63. We know that 63 you can write 7 into 9. If you have some kind of a certain, some kind of terms, it's simplify the numerator to do it, children. Then root 7 and root 7 get cancelled, turn up to 1 over root 9. What is the value for root 9? Root 9 is 3. So it will turn up to 1 over 3. Oh, other than that, you can do another technique. 63 you can write 7 into 3 into 3. So you can take 3 into 3. It's 9. Root 9 is 3. You can take 3 out and root 7 and root 7 get cancels in between this operation. Now let's try to make this question little bit advanced, right? You have to rationalize the denominator for 1 plus root 3. Then what is the term you need to multiply? Numerator and denominator should multiply with 1 minus root 3. 1 into 1 minus root 3 below denominator have to multiply with 1 minus root 3. Then 1 into 1 minus root 3 is 1 minus root 3. Denominator is 1 plus root 3 into 1 minus root 3. Then here we can expand the brackets. 1 into 1 is 1. 1 into root 3 is root 3. Root 3 into 1 is root 3. Root 3 into root minus root 3 is minus root 9. Then what you can understand is minus root 3 to plus root 3 get cancels. Numerator is 1 minus root 3. Denominator is 1 minus square root of 9. Square root of 9 is how much? In the 3. 1 minus 3. That is the answer 3. 1 minus 3 is minus 2, then you can simplify the numerator and you can get the final answer over here. Or simply you can say 1 minus root 3 if you multiply. No need of doing this multiplication. Straightforward, correct? 1 into 1 is 1 plus root 3 to minus root 3 is minus 3. That will turn up into the same answer here, right? Okay, if you come up with this question, 1 over 2 plus root 5. How to do this? Multiply both numerator and denominator by 2 minus root 5. 2 minus root 5. Then 1 into 2 minus root 5 is 2 minus root 5. Denominator 2 into 2, 4. My plus minus root 5 to root 5 is 5. 4 minus 5 is minus 1. If you divide this denominator by minus 1, you get the answer. Minus 2 plus root 5. How does it came? 2 divided by minus 1 is minus 2. Minus root 5 divided by minus 1 is plus root 5. Or other than that, you can do the expansion as this, but it's quite take long time. You can just multiply 2 into 2 is 4. Root 5 to minus root 5 is minus 5. Simply you can get it because intermediate terms get cancelled as shown in this example itself. Right, okay. Let's come up with part C. Right. If you come up with part C, the question is 1 over 3 minus root 7. How to rationalize it? You can multiply both numerator and denominator by 3 plus root 7. 3 plus root 7. Then 1 into 3 plus root 7 is 3 plus root 7. Denominator is 3 minus root 7 into 3 plus root 7. You can keep this one here. This question you can write 3 into 3 is 9. Minus plus minus root 7 to root 7 is 7. Because the intermediate terms get cancelled, no need of doing the expansion as this. Anyway, intermediate terms get cancelled. So the answer is 3 plus root 7 divided by 9 minus 7 is 2. That is the answer over here, right? Next question we need to rationalize is 4 divided by 3 minus root 5. Then what you need to do, multiply both numerator and denominator by how much? The denominator here is 3 minus root 5. Therefore, you need to multiply with numerator and denominator both by 3 plus root 5 and 3 plus root 5. 4 into 3 is 12. 4 into root 5 is 4 root 5. 3 into 3, 9. Minus root 5 into plus root 5 is plus minus 5. Then 3 minus 5 is 4. 12 plus 4 root 5 divided by 4. Now you can see all the terms you can divide by 4. Then 12 divided by 4 is 3. 4 root 5 divided by 4 is root 5. That is the final answer for that, right? The next question is 3 minus root 2 divided by 4 minus root 5. Then what you need to do, multiply both numerator and denominator by 4 plus root 5, the opposite of this. This is minus, you have to multiply 4 plus root 5, both numerator and denominator. Then what you can get, 3 minus root 2, this much, and denominator you can simplify as 4 into 4, 16, minus root 5 plus root 5 is minus 5. 16 minus 5 is 11. Then I'll multiply this numerator as well. 3 into 4 is 12. 3 into root 5 is 3 root 5. Minus root 2 into 4 is minus 4 root 2. Right. Then minus root 2 into plus root 5 is how much? Plus minus minus 2 into 5 is 10. Then you can see that there is no further simplification. That is why I just simplify at the last section. If you want, you can do the simplification from here itself. You can write it below and write the final answer. You will obtain the same answer again. Right. If you come up with the question number G, that is 5 divided by 2 plus root 5. Then both numerator and denominator multiply by opposite of this 2 minus root 5. 5 into 2, you can say 5 times of this much. I'll simplify the denominator. 2 into 2, 4, plus minus minus, root 5 into root 5 is 5. 4 minus 5 is minus 1. Numerator is 5 times of 2 minus root 5. Then if you divide this one by minus, what happened? This 2 turn up to minus and this minus turn up to plus. So turn up to 5 times of root 5 minus 2. Or if you feel like this is hard, you can use your calculator and just multiply it. You can verify your answer with that, right? Okay. The next question is 5 root 2 divided by root 8 minus root 7. Then what you need to do? Rationalize denominator means multiply both numerator and denominator by opposite of this, root 8 plus root 7. Then 5 root 2 into root 8 is how much, children? 5 root 16. 5 root 2 to root 7 is 5 root 40. divided by denominator is root 8 into root 8 is 8 minus plus minus root 7 root 7 is 7. So it should be 8 minus 7 is 1. Then 5 into root 16 is, what is the value for root 16? Root 16 is 4. 5 into 4 is turn up to 20. 5 into 40 root 14 is 5 root 14. That is your final answer. All right. Then we will come up with the next question, that is 11 divided by 3 plus root 11. Then what is the conjugate of 3 plus root 11? That is 3 minus root 11. Multiply both numerator and denominator by 3 minus root 11. Then 11 into 3 is, you can multiply 11 times of this. I am going to simplify the denominator. 3 into 3, 9. Root 11 into minus root 11 is 11. Return to minus 2. Then if you divide this one by minus this one, this 3 turn up to minus and this minus 11 to plus 11. So plus root 11, sorry. So you can write the answers 11 into root 11 minus 3. Here what I did was I just remove this minus from here and put this minus into numerator. 3 divided by minus is minus 3. Minus root 11 divided by minus is plus root 11. That is what it happened over here. Right? Okay, right. Let's go to the next question. In this question, we need to find root 3 minus root 7 divided by root 3 plus root 7. What you need to do? Multiply both numerator and denominator by opposite of that. That is 3 minus root 7. Then root 3 into root 3 is root 9. That is 3. Root 3 into root minus root 7 is minus root 21. Minus root 7 into minus 3 is minus root 21. Minus root 7 into minus root 7 is plus 7. Minus minus plus root 7 to root 7 is 7. If you get the denominator, you can write roots into root 3 is 3 plus minus minus root 7 to minus root 7 is minus 7. 3 minus 7 is minus 4. If you simplify 7 plus 3 turn up to 10. Minus root 21 minus root 21 is 2 times of minus root 21. If you are confused with this simplification, refer our first video. If you want to add root 21 plus root 21, sorry, minus root 21 minus root 21 is minus 2 times of root 21. You cannot add the terms inside the square root. We have already learned this logic in our Surds addition in our first video. So this is your final answer. You can divide both sides by minus 2 and you can obtain the answer. If you have managed to obtain this answer, even sufficient for this. The other one is for the simplification. If you want, you can use a calculator to obtain from this answer and this answer itself if you feel like confusing. Then the next part of it, that is root 41 plus root 29 divided by root 41 minus root 29. From which number you need to multiply with addition of this root 41 plus root 29, the numerator and denominator. That is a rationalizing process. Then root 41 into root 41 is root 41 and root 41 into root 29 is 41 into 29, and there's another term. To root 29 into root 41 is another root 29 root 41. If you multiply with these two, there are 2 times of root 41 into root 29. That is how this 2 came, because one from this one with this and other one from this one with this. There are 2 times of such terms, right? Plus root 29 to root 29 is just 29. Then you can add 41 with root 29 plus 2 times of. If you expand this bracket, you will obtain 1189 divided by the denominator. 41 into 41 is 41 minus plus minus root 29 into root 29 is just 29. 41 minus 29 is 12. Then you can obtain your final answer by simplifying both numerator and denominator by 2, and you can obtain the final answer over here, right? If you feel like this step is hard, you can keep your answer over here. Right. The next extension is rationalize the denominators and simplify, right? Okay. This is the situation where a square comes to the denominator, right? Okay. 1 over 3 minus root 2 squared. When you have a square, what you need to do first, do the simplification with the numerator. 3 minus root 2 squared is 3 minus root 2 to 3 minus root 2. Let's see what is the final answer. 3 into 3 is 9. 3 into root 2 is 3 root 2. 3 to minus root 2 is 3 root 2. Root into root 2 is root 4. That is 2. Then 9 plus 2 is 11. Minus 3 root 2 minus 3 root 2 is minus 6 root 2. Then this is not in a rational version of the denominator. So what you need to do is rationalize the denominator. How can you rationalize the denominator? Multiply both numerator and denominator by opposite of this 11 plus 6 root 2. That is why I already did over here, right? Okay. Then if you multiply with 1, 6 plus, sorry, 11 plus 6 root 2, answer is 11 plus 6 root 2, then multiply the denominator, right? If you multiply 11 into 11 is 121, 11 into 6 root 2 is 66 root 2, minus 6 root 2 into 11 is this much. Actually, no need of doing this straightforward. You can write 11 to 11 is 121, minus 6 root 2 into plus 6 root 2 is minus 72. You just use the calculator and you can get it. 121 minus 72 is 49. This is the other way of getting this answer, right? Okay. Let's come up with the second example. In this example, the term where we need to find is 1 over 2 plus root 5 squared. That is 1 over 2 plus root 5 into 2 plus root 5. Then I'll expand the brackets. 2 into 2, 4. 2 into root 5 is 2 root 5. Root 5 into root is 2 root 5. Root 5 into root 5 is root 25. That is 5. 4 plus 5. How does this 5 came? Root 25 is 5. 4 plus 5 is 9. 2 root 5 plus 2 root 5 is 4 root 5. Right. With that, you can obtain the answer as 1 over 9 plus 4 root 5. This is not the rationalized denominator version. So what you need to do? You can multiply numerator and denominator by opposite of this 9 minus 4 root 5. 1 into 9 minus 4 root 5 is 9 minus 4 root 5. Denominator is 9 into 9 is 81. 9 into minus 4 root 5 is minus 36 root 5. 9 into 4 root 5 is plus 36 root 5. 4 root 5 into 4 root 5 is 4 into 4, 16. Root 5 into root 5 is 5. 16 into 5 is 80. Minus plus turn up to minus. Then you can cancel this 2. Turn up into 81 minus 8 is 1. 9 minus 4 root 5 divided by 1 is 9 minus 4 root 5 itself. Right? Okay. Then this question also, the part C is 4 over 3 minus root 2 whole thing squared. So that means 4 divided by 3 minus root 2 into 3 minus root 2. Right? Then if you expand the brackets, you will obtain the answer 3 into 3, 9. 3 into minus root 2 is minus 3 root 2. Minus root 2 into 3 is minus 3 root 2. Minus root 2 into minus root 2 is plus root 4. Root 4 is how much, children? 2. 9 plus 2 is 11. Minus 3 root 2 minus 3 root 2 is minus 6 root 2. Then multiply numerator and denominator both by 11 plus 6 root 2. Then 4 into 11 is 44. 4 into 6 root 2 is 24 root 2. Then multiply with this. 11 to 11 is 121. And you can just do this one as well. Minus 6 root 2 into plus 6 root 2 is minus 72. So you can cancel these two terms. 121 minus 72 turn up to 49. If you want, you can multiply everything and you can cancel out these two terms. But it's pretty easy. Rather than that, just multiply this one with this one with this and minus this one with this. That's a pretty easy way of getting the rationalized denominator, right? Because the reason intermediate term it cancels, no need of writing these two terms again and again, right? Okay. The next question also, I hope you can understand to how to use the same technique to obtain the answer over here, right? So this question is quite different, right? For this question, what we need to do is we need to get 1 over 5 plus root 2 minus 3 minus root 2. Let's see what the answer. 1. 5 into 3 is 15. 5 into minus root 2 is minus 5 root 2. Minus 5 root 2. Right. 3 into root 2 is plus 3 root 2. Root 2 into minus root 2 is minus root 4. Root 4 is how much, children? 2. 15 minus 2 is 13. Minus 5 root 2 plus 3 root 2 is minus 2 root 2. Then you have to rationalize the denominator. Multiply both numerator and denominator by 13 plus 2 root 2. Then numerator is just multiply 1 with 13 root 2 is 13 plus 2 root 2 is 13 plus 2 root 2 denominator. How to get it? No need of writing everything. You can write 13 into 13 is 169. Intermediate terms get cancelled anyway, no need of writing. Minus 2 root 2 into plus 2 root 2 is minus 8, children. 169 minus 8 turn up to 161. Right? Okay, that's the final answer. But this is the detailed step, just expanding this bracket. But anyway, these two terms get cancelled and only this term and this term will be remain at the final answer. In this question, what you need to do is 2 divide by 5 minus root 3 divide into 2 plus root 3. First, we will expand the brackets. 5 into 2 is 10. 5 into root 3 is 5 root 3. Minus root 3 into 2 is minus 2 root 3. Minus root 3 into plus root 3 is minus root 9. What is the value for root 9? It's 3. 10 minus 3 is 7. 5 root 3 minus 2 root 3 is 3 root 3. Then 2 over 7 plus 3 root 3. Then what is the next step? You have to rationalize the denominator. How to rationalize the denominator? Multiply both numerator and denominator by 7 minus 3 root 3. Then follow up the same step. You can obtain the answer 7 minus 3 root 3 divided by 11. If you come up with the last question over here, this is the some kind of exam style question. They ask simplify 3 minus 2 root 5 divided by root 5 minus 1, give you answer in form of p plus q root 5. What you need to do is, what they expect is, in this fraction there are no what you call irrational term in the expression. So that means they expect us to do the rationalizing the denominators. What you need to do? Multiply both numerator and denominator by root 5 plus 1. So this question is exact. When you happen to this question, you understand that it is rationalizing the denominator. How do you understand? Because in this question, there is no irrational denominator available in this answer. Then remember that when you are working out with this, you might get a fractional answer. So integer answers for p and q doesn't matter which way it varies, right? Okay. Then how to rationalize the denominator? Multiply both by opposite of this root 5 plus 1, root 5 plus 1. Then 3 into root 5 is 3 root 5. 3 into 1 is 3. Minus 2 root 5 to root 5 is minus 10. How does it came? 5 root 5 to root 5 is 5 into 2 is 10. Minus 2 root 5 into 1 is minus 2 root 5, right? Then 3 root 5 minus 2 root 5 is root 5. 3 minus 10 is minus 7. These two get cancels. Or other than that, you can write root 5 to root 5 is 5. Minus 1 into plus 1 is 1. 5 minus 1 is 4. So you can get the answer over here. Then this fraction is root 5 over 4 and the other answer is minus 7 over 4. Therefore, P is minus 7 over 4 and Q is 1 over 4. With that, you can get the final answer. So these are the areas where they expect us when you're working out with rationalizing the denominator. So all the possible questions are available in this video where they can ask about rationalizing the denominator. Hope you have understood the contents in this video. If you like this video, put a thumbs up and share this video with your friends. To watch my educational videos, please subscribe my channel and click on the bell icon. Thank you and see you from next videos.